आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, the question is, which of the following pairs of Lewis structure represent resonance contributor to the species? Okay, so out of all these four options that are given here, as you can see, okay, we need to tell that out of all these four options, out of all these Lewis structures, which one represent the correct resonance contributor to the species. Okay, so basically we need to check which ones are the correct resonance structures. Okay, first of all we should be clear what is resonance. Okay, resonance is nothing but the delocalization. It is nothing but the delocalization of pi electrons. Delocalization of pi electrons. Okay, in adjacent p orbitals. Alright, so that is your that is your resonance. That is delocalization of pi electrons in adjacent, or you can say in parallel p orbitals. Alright, so that is your resonance. That means only electrons are moving in this. That means only electrons changes their place or they moves in the structure. Alright, so that is your resonance. No atom changes its place. No atom changes its place. That means no atom is going to be shifted from one atom to the another. All right, only electrons, delocalization of electrons is taking place here. All right, so that is your what? That is your resonance. Okay, so now let's see the first option. If you see the first option here it has HCH double bond NN, and here it has HC double bond NHHH. If you see here nitrogen is present, 2 nitrogens are here, and here only 1 nitrogen is present and hydrogen is there on its place. So the structure is incorrect, right? So this structure is incorrect, which is telling you that the answer is also incorrect. But if you see, let's say, if you see this option, we know that nitrogen is more electronegative. The electrons will go from, if we have to break the pi bond, this pi bond will go to this nitrogen. Then your nitrogen should get a negative charge, whereas it is getting here a positive charge, which is again incorrect. So thus your A option is correct. These are not the correct resonating structures. Alright, now let's see the B. If you see B here, it has this structure and this. So again, I told you that electronegativity of nitrogen is greater than carbon. Right? We know that nitrogen atom is more electronegative than carbon. So here the bond is going to be, so nitrogen will be pulling electrons, right? So if we have to break this bond, then the electrons will go towards nitrogen atom. So your nitrogen will get a negative charge. So you will get this structure. You will get this structure. Here nitrogen, because nitrogen is pulling electrons away, right? So nitrogen will get a negative charge. Alright, and of course a lone pair is there, and because the electrons are going towards nitrogen, carbon is getting no electrons, so that's why it will get a positive charge. Okay, so this will be a structure forming. This will be the structure that will form. So if you match this, it is the same structure: carbon with a positive charge, nitrogen with a negative charge. So these are the correct resonance structures which are contributing to the species. Right? So these are the correct resonating structures. So B is your answer. Let's see other options as well. If you see this C option here, if you see here, this carbon is forming 5 bonds, 1, 2, 3, 4 and 5. So of course the structure is incorrect. That means the option will be incorrect, of course. But also let's see, if you try to, if you pull these electrons, it will go like this. Oxygen, if you see how the electrons are moving here, although this structure is not possible, so of course the answer is incorrect. But still, if we see the electrons, we know that oxygen is electronegative. It will go here, it will get a negative. So what is happening here? O is getting a negative, but it is also getting a hydrogen. That means one hydrogen from here is moving to this oxygen. And I just told you that no atom is going to move. Only delocalization of electrons is allowed. So that means these structures are not the correct resonating structures. Alright, so C is obviously incorrect. But it is also incorrect because this structure is not possible. Here this carbon and both of these carbons are getting 5 bonds, which are not possible. We know that carbon only forms 4 bonds, right? So this is incorrect Answer C is incorrect. Now let's see the option D. Here if you see it has CH3, CH2OH. Here it is getting CH3 and OCH3. So here what is happening? Whole CH3 group is migrating from here to this oxygen. Right? So that's why, because as I said earlier that no atom is going to move, that's why this answer is incorrect. Okay, because these are what? These two options are metamers of each other. Right? We know that metamers, right? Structural isomers. Right? Where the number of carbon atoms on both the sides of the functional group, that is here, for example, here it is oxygen, right? So the number of carbon atoms here on both the ends of the functional group are different. So that those are your metamers. Here it has 2 carbon here. Here it has 1 here and 1 here. So that's why these are metamers. While they are not resonating structures. Okay, they are structural isomers, but they are not your resonating structures. Okay, what are structural isomers? Structural isomers are the isomers which have the same molecular formula. As you can see, these two have same molecular formula, but they have different structures. So their structure is different. Alright, but these are not resonating structures. So thus your D is also incorrect. So your correct answer is B, this one. Alright, I hope you understood. Thank you so much.
क्लास 6 से 12 से लेके नीट IIT जेईई मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।